And now we need our calculator. So our calculator is going to help us determine what portions of this data set we need. Let's go ahead and get our calculator. I'm going to go ahead and open the file. And here's our calculator. Let's take this over to Microsoft Excel. And we'll just duplicate it there. So let's call it Bernoulli calculator. And we're going to put it into the same folder here, Bernoulli's equation. Okay. So when trying to calculate, when we're using Bernoulli's equation, if you remember the theory, the theory is basically saying all we need is y1. Y1 is up here. Okay, that's all we're going to need. If I bring this back, I don't know how to say it better than that, but here's our theory. G is equal to, that's not even as good as this. We need 2GY. That's it. So that lets you know the only data set that you need in this calculator for Bernoulli, to calculating the initial velocity for Bernoulli, is the Y data section. So let's go back to Bernoulli's collected data and let's find the Y. Everything is already spread out, you'll see, and we want to copy this Y column. We're going to put that back into our calculator. So let me just paste this. So when I paste it, you'll see that we have an average Y displacement here, and we have an initial velocity. Now, this initial velocity is ideal. It's for a superfluid. A superfluid is inviscid, all right? First time mentioning a superfluid to you, but it's for an inviscid fluid. So we're not taking into account the forces that are going to pull it back. So what would you think the real solution is going to be? Is it going to be greater? So are the forces that's holding it back going to cause the velocity to go forward or to increase, or are they going to cause it to decrease? So the next thing for kinematic theory, we already know that we need both X and Y. I mean, you know, that's what we've been doing. Should have a fairly good foothold in how we're treating, how we're utilizing kinematic equations. So now let me go ahead and just open this up so I can see, and it's very important, so that I can see which columns I am actually copying. The only columns that I need, if you guys remember, was X and Y. If I go back to my theory here, you'll see right now, let me click on this. See right down here, we just need X. This is going to help us with the initial velocity, and we need T, but T is dependent on Y. So that's all we need. Go here, I'm going to go ahead and select on X and Y. I'm going to copy that, and we need to go back to our calculator. And once we go back to our calculator, we're just going to paste that information in. So I can just paste it, and you'll see the calculations are being done right here, just like we've done several times before. Average displacement in the Y, average displacement in the X. We have our time of flight here, and we have our initial velocity. And notice the initial velocity is a little bit less. It's less than the initial velocity we calculated for Bernoulli's, which kind of fits with how we're thinking. Bernoulli's is ideal, kinematic is real. It's what's really happening. We're looking at where it starts and where it ends. And then we have our percent difference between the two. It's just about 10% or 9.65. This is our precision. And so we can use this theory, but when we use water, we should pretty much expect that, especially at this rate, that the water is going to be, the calculation will be off about 9.65%. Okay? that is it. Please upload this folder. Send me a link to this folder in your Moodle share, please. Thank you.